Well, howdy doody, geographers. We're going to talk about the processes that shape landscapes. Write down that title, Processes that Shape Landscapes, and the date. Learning goals. We have 3. You're going to know the 4 forces that shape landscapes. You're going to know why soil is important. And you're going to know Australia's landform regions. I'm going to show you a map and also give you a text explanation of what they are. There's 4. Right. The 4 forces are weathering. I've got a really cool video explaining weathering and erosion at the end of this. Weathering is the breaking down of rocks from rain, temperature, and biology. So it could be physical, that's water freezing and thawing, chemical, rocks that dissolve, or biological, roots and algae that eat rocks. So how do we get small rocks from mountains? There might be a crack in a mountain and the water seeps in, and then the water freezes, and when water freezes it expands, cracks, makes the crack in the rock a little bit bigger, and over years and years and years, that water thawing, freezing can make even an entire mountain break off little bits at a time. Yep. There's also chemical weathering, so that's rocks that dissolve. So if you remember us talking about karst landscapes, that's when like acidic water slowly dissolves away rocks and can make underground caverns, stuff like that. And then biologically, trees that might be growing in rocks, the roots might grow into a crack, and as the tree gets bigger, the root gets bigger and forces that crack open, and it might break the rock up. Then you've also got these weird little algae that even eat rocks. Madness. Erosion is another one. That's when things are worn away by wind, water, and ice. So these forces might not seem that powerful, but when they are hitting a rock day after day after day after day for years and years and centuries and thousands of years, wind, water flowing through things, and ice can all slowly erode, wear away, all kinds of stuff. Yeah. Think about a river. Rivers are usually at the bottom of valleys. They have carved a massive path through the rock over thousands and thousands of years. The third of the 4 forces is transportation. So that's when all of this material that breaks off or is worn away by weathering and erosion, wind or water moves that material. So a river might be flowing away from a mountain and carry all of the mountain's rocks down, or wind might blow all of that stuff. And then finally you've got deposition, that when it gets deposited, that's the way to think about it, deposit. Once something is moved away in the transportation phase, it gets deposited. And new landforms might get formed or built when that material stops being deposited. So, simple example, let's show you it on a diagram. You might have all of your soil. So let's go through the stages, right? So the first one is weathering. So the rocks get made, they come up through the ground by volcanoes or tectonic plates pushing rocks together to create mountains. You've got these mountains weathering. Remember, chemical, biological, and physical processes like freezing and thawing, or tree roots, or algae, or acidic water wearing away limestone. That gets weathered. It can also be eroded using wind, water, rain, and ice. And then it gets transported. So in this example, it's being transported down a river, and then it gets deposited. And if enough stuff gets deposited out there, you might get a little island or whatever. And that's the cycle. And eventually this stuff gets pushed down underground and becomes sedimentary rock. There you go. They're the 3 types of rocks, just for your own information: igneous, metamorphic, and sedimentary. Sedimentary is made by sediment, by it being squashed over thousands and thousands of years. Igneous is the fresh stuff that comes up from this layer of magma. There's a massive layer of molten rock underneath your feet right now. Right, let's talk about soil. As mentioned in an earlier video, remember Australia's got quite weak soil. But what's the purpose of soil? It provides nutrients for plants. And without soil, nothing could survive. So the health of soil is really, really important. And the world does have a problem with soil health. We are over farming our soils and making it have less and less nutrients. So we're going to have to do something about soil health in the next 50 years, or we're all going to die. We're going to run out of food. Yep, as mentioned, Australia's got it's got poor soil. Doesn't have a lot of nutrients in it. Its soil is dry and its soil is salty. Copy all those notes down. Let's have a look at a pie graph. That shows you what soil is made of. There you go. Very interesting. So eroded rocks, yeah, remember the 4 processes? That's how we get all of the eroded rocks in our soils, is from it eroding away and being transported down to wherever that dirt is. A quarter of soil is air, and a quarter is water, and only a tiny little 5% is all the organic matter, and that's all the nutrients, that's all the good stuff. Obviously there must be air in soil, because otherwise how could insects live in the soil if there was no air down there for them to breathe? This is soil under a microscope. There you go. And you can see all the little stuff that's alive down there. Creepy. This thing here, you don't need to write any of this down, I just want to show it to you. This is a soil profile. So soil profiles is like a way of measuring and describing what's in the soil. So they're called horizons. Yeah, Horizon O is the organic matter. So that's right at the top. That's that thin little layer there of decomposing stuff, right? So if plants grow and then die, they start decomposing, i.e. turning back into dirt. That's at that top level there, Horizon O. Horizon A below it, that's topsoil. This is where most of the nutrients are. This is the most important bit for farming. Then you've got Horizon B, the subsoil. And then Horizon C, that's just mostly weathered rock that's not been broken down enough to be soil. You might still get a little bit of nutrients leaching down there, and then you got underlying layer of solid rock, and that's not soil. So there you go, soil profile. Horizon O, that's decomposing matter. Horizon A, topsoil, really important for growing. Horizon B, the subsoil. And Horizon C, the parent material, and then you got your rock underneath it. That's the soil profile. Let's talk about Australia. Australia's got 4 landform regions. The coastal lowlands with lots of river valleys, which is us here in Melbourne. We've got the eastern highlands, that's tablelands, so high flat areas. You get your central lowlands, that's all the deserts. I spelt basins wrong there. There shouldn't be an I there. B-A-S-I-N-S. And then we've got the Great Western Plateau. So that's the mega desert. And I want to show you, this will make more sense when I show you a map. But fun fact, Australia is the world's driest continent that's inhabited. I had to say inhabited as in, inhabited means where people live. Because Antarctica is even drier than Australia, but no one lives there permanently. It's just a few random scientists there. Australia's flat because it didn't have any volcanoes, and erosion and weathering have had more time to wear down the mountains. That's why Australia's so flat. Yeah, very flat, very dry. So take all those down and let's have a look at those 4 landform regions in a map. Coastal lowlands. Well, firstly, let's talk about bolts. What elements is this map missing? Border. No border. Orientation. Yep, we got it there. Legend. Yep. Title. Yep. Scale. Yep. Source. No, but I could have written it in Jacaranda textbook. Anyway, so that's not bad. It's got more of the bolts. So we see we've got the coastal lowlands all the way around the coast. The central lowlands here. Now there. You've got the eastern highlands, so these you got Australia's mountains are found here, and then you've got the Great Western Plateau, and that's mostly desert there. Fun. Okay, your activity is just to answer 3 questions. Fairly straightforward. Now, when you answer these questions, remember to include the question stem in the answers. So, for example, question 1, why is soil important? You don't need to write the question, you just write, soil is important because, blah, blah, blah. Yeah. For question 2, you'd write, the 4 main processes shaping the earth are weathering, erosion, transportation, and deposition. But you need to define those 4 things in your own words. Don't just repeat the notes from earlier. And finally, human activity could contribute to weathering and erosion by... what influence do we have over the wind, water, and ice? Anyway, have fun with that. Got to watch Crash Course Kids video about weathering and erosion. Very fun, very short.
This is Earth, home to 7 billion plus people, 7 continents, and all kinds of amazing plants and animals. This is what Earth has looked like for a long time, and will probably continue to look like for a long time, right? Yes, and no. Sure, this is what Earth looks like from space, but even though it looks pretty much the same from whenever we view it from afar, once you zoom in on it, you can see it's always changing. On a small scale, things like moving water shape the Earth's landforms, the natural features of the Earth's surface. On a bigger scale, the gradual shifting of the Earth's crust is slowly moving even bigger things, like the oceans and the continents. So one day, our planet will look different, maybe a lot different from how it looks now. So how exactly does water shape Earth's landforms? Or to bring it back to the spheres we've been talking about, how does the hydrosphere affect the geosphere? To understand that, we need to discuss weathering. I'm not talking about the weather, like if it happens to be sunny or cold or foggy outside your window right now. I'm talking about weathering, the process that takes place as rocks and other parts of the geosphere are broken down into smaller pieces. Weathering can be caused by water, air, chemicals, plants, or even animals, including us. And there are 2 types of weathering you need to know about: mechanical weathering and chemical weathering. Mechanical weathering is the process of breaking big rocks into little ones. Frost, ice, the roots of plants, running water, or heat from the sun can all cause mechanical weathering. Chemical weathering involves the changes that some substances can cause in the surface of the rock that make it change shape or color. Things like carbon dioxide, oxygen, and acids can all cause chemical weathering. And when rocks have been weathered and all broken down and are later moved by natural forces like wind, water, or ice, that's called erosion. Weathering and erosion sound pretty similar, right? Well, yeah. But not exactly. Think of weathering as the hammer that breaks down the rocks. Erosion is the process that carries those rock fragments away, or put in a way we're all familiar with. Weathering helps make a mess, and erosion helps clean it up. Let's take a trip to the beach to see what part the hydrosphere plays in weathering and erosion. This is a picture taken from space of the coastline of Massachusetts in the northeastern United States. It's part of a landform called Cape Cod, and the picture shows what the beaches and islands around it looked like in 1984. Now look at this photo from 2014. What's different? There are actually more islands in 2014 than there were before. Back in 1984, that long strip of land was North Beach. Now, that strip of land has been chopped up into separate islands. The top part is North Beach, the middle area broke off into North Beach Island, and the bottom part is now called South Beach. So, how did that happen? Well, moving water is a major cause of erosion, and there's a lot of moving water in the Atlantic Ocean. The intense energy of ocean waves crashing on shore causes pieces of the rocky, sandy coastline to break into smaller pieces or to weather over time. Then, natural forces like major storms and rising sea levels then move or erode these smaller pieces. Day to day, you might not notice any dramatic changes, but over the course of 30 years, well, as these pictures show, coastlines can change a lot. So what can we take away from this? Well, we saw that water can weather and erode Earth's landforms, and that's just one example. There are so many others, like floods weathering valleys or glaciers eroding mountains. Let me break it down for you this way. See what I did there? The hydrosphere shapes and sometimes moves the geosphere. One last joke before I sign off. What did the geosphere say to the hydrosphere? You crack me up.
Right, last thing, write that down. Reflection activity. We're going to do a CSI, and that stands for Color Symbol Image. So on the topic of processes that shape landscapes, I want you to just write down what comes to mind, what colour comes to mind when you think about weathering, erosion, transportation and deposition. What symbol could you draw that sums up those 4 processes? And what image? Sketch a little image. So I just want a colour, a symbol like an icon, and then a little sketch picture. Maybe you could do a sketch picture of the whole process, like in that diagram. And that is all. Thank you so much. And do not ever stop keeping it real.